Hi, I'm Teacher Thomas. Welcome to A-Level Maths. This is 9231 Further Probability and Statistics. Topic 5, Probability Generating Functions. In working with a probability generating function, we'll take a probability distribution and use the summation form of the probability generating function to produce the probability distribution in algebraic form. The summation that we will work with is the probability generating function for the variable x is the sum of t to a range of powers of x times the probability that the variable equals a range of x's, which also equals the expectation of t to the power of x. Note that the variable is x. It could be y or some other variable. The variable isn't t. The t is going to be useful in later calculations, but the variable we're working with here is x. So let's take a probability distribution and look at how we would apply the function to the distribution to create an algebraic expression. Our possible outcomes and the probability of those outcomes for 4 outcomes: 2, 4, 5, and 10, with probabilities of 0.1, 0.2, 0.3, and 0.4. I'll apply my rule. Looking at the summation, we're summing t to the power of x times a probability. The probability is going to be the numeric value, so I'm going to write that first. The first probability is 0.1. Notice the relevant x is 2. The output, or the result of 2, has a 0.1 probability. Our summation notation indicates that we write that as t to the power of that x, t to the power of 2. This is a sum, so we then add the next term, using first the probability of 0.2, and then looking at the product of that 0.2 and t to the power of the relevant x. That x output is 4. Next term would be probability of 0.3 times t to the power of the relevant x is 5. And the final term would be 0.4 times t to the power of 10. We'll see applications of the probability generating function in a later lesson. Let's look at creating probability generating functions in 4 particular scenarios, starting with a discrete uniform distribution. Here is my probability distribution. I'll now work through creating my probability generating function, which is produced here. And I can simplify algebraically. I see the common terms of 0.25 and t. Here's my factoring. And the expression in brackets has an interesting characteristic. I might be asked to present the probability generating function in the form of a times 1 minus r to the power of n over 1 minus r. And I want to recognize that this is a geometric series with a representing the first term, n representing the number of terms, and r representing the ratio. Well, this isn't our final function, but looking at the portion that's in the brackets, the first term is 1, the number of terms 4, and the ratio is t. And with those values, I can adjust my general geometric series, changing the a to 1, changing the n to 4, and changing the r to t. Now looking over at the left, in the actual probability generating function we're working with, we're multiplying the brackets expression by 0.25. And the a on the right, which I've changed to 1, I'm going to multiply by 0.25t. And my final result will be a 0.25t times 1 is 0.25t times 1 minus t to the power of 4 over 1 minus t. Notice we have 3 equivalent forms of the probability generating function. Ultimately, we have arrived at the format following the requirement in the problem of a times quantity 1 minus r to the power of n over 1 minus r, if you're given the requirement to follow that format. This ends part A of the lesson. In part B, we'll look at probability generating functions for binomial distributions, geometric distributions, and Poisson distributions.